Hello all, welcome to the third session of the introduction to functions, and here in this session we are going to do a deep dive on the linear functions. As we saw in the previous sessions, a linear function is something which has a degree of 1, or essentially the highest power of x is 1. We also saw that the shape of a linear function is a straight line. Now the straight line could be in a different ways, right? A straight line could be something like this going upward, right? A straight line could be something like this going downward, and so on and so forth. So we are going to now understand that what is that which determines how that straight line will look like. There could be a situation wherein the straight line is just horizontal, right? There could be a situation wherein a straight line is like vertical, right? So essentially there are four different scenarios in which any straight line could happen. It could either be having a positive slope going upward, it could either be going downward, it could either be horizontal, or it could be either vertical, right? So we are going to do a deep dive in terms of understanding what is that which determines how the straight line will look like pictorially, and then we will also understand mathematically or algebraically what does it mean. So there is something called as the slope, which determines the actual shape of the straight line. Slope is nothing but the steepness of the straight line or the linear function, right? Mathematically, it is determined by the change in y divided by the change in x. Essentially, we're trying to understand how fast is the y changing with respect to x, or basically how much the y is changing for a unit change in x, right? So let's take that in the context of these two examples. Let's say we have line L1, which is like this, and the other line L2, which is something like this. Let's calculate the slope of each of these two lines and try to correlate them with slope. So the slope of the first line, by definition, would be change in y over change in x, right? We got to take any 2 points which are more convenient to us with respect to the given graph. Here in this case, for x equal to 1, y is 5. For x equal to 3, y is 8, right? So let's take these 2 points and see how the y is changing for a unit change in x. So the change in y is going to be, when you go from point 1 to point 3, the change in y is from 5 to 8. So 8 minus 5, the final value of the y minus the initial value of the y, divided by the final value of the x minus the initial value of the x, which is 1 in this case. So 3 over 2, or 1.5. So this is the numerical value of the slope for line L1, right? Let's do the same exercise for line L2. So the slope here is going to be, again, we are going to take any 2 points. In this case, we'll take these 2 points, 1 and 3, because we have the y values for those corresponding points. So the final value of the y minus the initial value of the y, which is 6 minus 4, divided by the final value of the x minus the initial value of the x. So 3 minus 1, which equals to 2 over 1, 2 over 2, which is equal to 1. So we do see that the slope of line 1 is more than the slope of line 2, and which is kind of obvious just by looking at the lines as well, because line 1 is more steeper as compared to line L2. That's why I mentioned in the beginning that slope is nothing but the steepness of the line, how steep the line is. The higher the steepness, the more the slope. The lower the steepness, the lower the slope. Okay, so let's take example of two special cases. Let's say line 1 is a horizontal line and line 2 is a vertical line, and let's try to calculate the slope of these two lines as well. And if you would like, maybe pause the video and try to do it on its own, and then later come back to us to the video and check out. So the slope of the line 1, again, change in y over change in x. So let's say we take these 2 points, 1 and 3, right? The corresponding y value for x equal to 1 is 3, and the corresponding y value for x equal to 3 is also 3. So in this case, both the y values are 3. So final y value minus initial y value divided by the final x value minus initial x value. So this will be 0 over 2 is equal to 0. So we see that the slope of a horizontal line is 0, which makes sense because y is not changing at all with respect to x. It's like a flat line. Let's do the same exercise for line 2. Again, let's take any 2 points. Let's say we take these 2 points. For x equal to 3, the value of y is 1 here, and for the same value of x3, the value of y is 3. So the change in y would be the final y minus initial y, which is 3 minus 1, divided by the change in x. And by the way, there is no change in x because x is constant at 3, right? We are not moving x. So the final x minus initial x is 3 minus 3, which is equal to 2 over 0, which is undefined, right? Anything divided by 0 is undefined, and hence the slope of a vertical line would always be undefined, no matter how the vertical line looks like. We can draw a vertical line like this. The slope of this line would still be undefined. Coming back to the horizontal line, again the same thing. I can draw a horizontal line like this, and the slope of this would again be 0 for the same reason. So let's do a mini exercise of comparing the slopes of 2 lines L1 and L2 as shown on the board. Right. So the slope of L1, change in y over change in x. So let's say that these are the 2 points which we choose because we know the x values and the y values for both of them. So let's say this point is A and this point is B. The y value of B is minus 3. It's the final value. The initial value of y was 0, so minus 3 minus 0, divided by the change in x, final value of x minus the initial value of x. Right, so we are going from A to B. A is our initial point and B is our final point. So final y minus initial y divided by the final x minus the initial x. So this becomes minus 3 over 2, which is minus 1.5. So as we see, the slope of this line L1 is negative because y is decreasing as we are going ahead with x, right? Let's do the slope of line L2. As we saw in the previous session, the slope of line L2 will be 0 because there is no change in y. And we can confirm that by taking again 2 points. Let's say this is A dash and B dash. The final value of B dash is 3. The initial value of A dash is also 3. So final y minus initial y divided by the change in x, which is 3 minus 2. So essentially it is 0 over 1 or 0, right? So the slope of line L2 is 0 and the slope of line L1 is minus 1.5. If someone were to ask to compare, the slope of line L2 is more than the slope of line L1. Now that we understand how to interpret a linear function or a straight line graphically, let's see how do we represent it mathematically and where does the slope which we talked about in the previous session plays a part in that equation. So y is equal to mx plus b is the standard form of a linear equation wherein m is nothing but the slope which we have been talking about all the while, and b represents the y-intercept of the straight line or the linear function, and y-intercept is nothing but the point where the line cuts the y-axis. Essentially, for example, if we have something like this, then this point becomes the y-intercept, and this is the point where x is equal to 0. So let's do a mini exercise of finding the slope and the y-intercept of a linear function, something like this, right? If you'd like, you can pause the video and try it on its own before we do it together. Before we try to find the slope and the y-intercept, we got to remember that the standard form of a linear function is given by y is equal to mx plus b, right? So before we determine our m and b, we have to make sure that we have isolated y, right? And when we try to do that, we're going to bring the y term on the left side and we're going to bring the 9 term on the right side. So we're going to do plus 3y and plus 3y. The y cancels out here and we are left with 3y minus 9 is equal to 6x. We're going to move the 9 to the right side, so plus 9 and plus 9, and we are left with 3y is equal to 6x plus 9. Even at this point of time, we are not in a position to determine our m and b because it has to be just y. So we got to divide both the sides by 3, which give us y is equal to 2x plus 3. This is our final form of the equation, which is exactly the replica of our standard form. Hence, this 2 is our slope and this 3 is the y-intercept. So let's quickly see how to solve a linear function. Suppose we have a function y is equal to 2x plus 3. So far we understand that this linear function has a slope of 2 and the y-intercept of 3. Now if somebody comes to us and says that, okay, solve for 2x plus 3 is equal to 0. What does it mean? It essentially means that they are asking us to find the value of x for which the value of the function or the value of y will be 0. Or in other words, the x-intercept, right? So when we solve this, and when we say minus 3, and we get 2x is equal to minus 3, and then finally we get x is equal to minus 3 over 2. What does this represent? This represents the x-intercept, or the value of x where the value of this whole function is 0. So this is the value which is minus 3 over 2. Hopefully this session gave a good perspective in terms of understanding how we represent a linear function graphically, mathematically, what are the different aspects to it like slope and y-intercept, how do we solve a linear function, what is the meaning of solving a linear function. In our next session, we are going to talk about the system of linear equations, or basically how to solve two linear equations together, or what is the meaning of solving two linear equations together. Hopefully you guys like the video. Please do like and subscribe. Thank you.